All right, let's go. Dimitri will start.
All right, you can just go to the next slide. Let's just start from the start. We're saying that like Temporal is workflow engine, but what does it even mean? Because there is a lot of workflow engines on the market, and like in general, this word for a lot of people means something from like business domain, what is used by like business level people to create high level workflows, usually in like graphic editors, etc. Temporal is very different from majority of like workflow solutions because, as we always say, Temporal is workflow as code. So our main users and our main focus are engineers and engineers applications. And that's how we are very different in terms of our positioning and in terms of our use cases from a lot of other workflow engines. And like just for the there's a lot of applications, potential applications of workflow, but for the point of today's meetup and discussion, let's just focus on one of pretty popular problem that we currently have in general in our community and in our projects. It's microservices architecture. When we have microservices architecture, we pretty often need to make consistent changes across microservices, across several databases, across several endpoints, etc. And basically, the typical patterns and typical solutions for the problem is either orchestration or choreography-based saga. So a very good problem for a workflow engine is actually an orchestration pattern in microservices. When we basically have some central component, central player in the system that performs a sequence of actions in the microservices environment and setup. This pattern and this approach has a lot of challenges because everything can fail. Every step can fail internally of the distributed transaction or distributed process. Network can fail, and the orchestrator itself that performs the changes can fail. And we as engineers on every project that we come, we reproduce more or less the same system, the same architecture to recover from these situations. We create queues and message brokers. We create some kind of persistent state that allows us to recover when something goes wrong. We create Zookeeper to be able to scale and be able to distribute the work in the cluster when our project get any significant load. So basically, every microservices architecture and approach reproduces the same setup, more or less, that addresses the same set of problems. It is expensive, it is convoluted, it is hard to maintain for DevOps, and also it is extremely hard to, for observability point of view and from actual writing point of view. Instead of just calling endpoints and performing actions, we have to schedule events. We have to write all the code that process all kind of failure modes and recovers from all kind of inconsistent states, etc. So Temporal basically provides a solution for all kind of issues that can happen in such an environment. Temporal has two components, Temporal Server and Temporal SDK. So SDK can be for like different languages, but they all provide more or less same functionality. And Temporal server provides an ability to store a workflow state as a serialized representation of what actually happened in the workflow. And we call this a history. Also, temporal server provides an ability to schedule triggers in the future. You probably know all the situations when suddenly your project needs something like, I need to execute it tomorrow. And we start to either bring all kinds of additional components into the system, like schedulers, or even worse, write our own, especially if we need to work with large amount of events. So temporal server provides an ability to schedule triggers in the future. Temporal SDKs provide an ability to actually serialize the execution of your code as a history, as a sequence of events. And it also provides a series of abstractions, workflow workers and activity workers, to actually scale and execute the code. So it's a framework for code execution. So Tiho, can we go to the next slide? Let's just dive into like very specific example of a very specific, very simple workflow and how this workflow can even be serialized into some sequential representation. So here we basically have a very simple function that checks and refreshes status of the user account, and after that sleeps for 30 days. So basically here we just reproduce something like every month we need to perform some action on a user, and after that wait for the next month. This can be represented as basically just 3 lines of code. It's a loop, it's a action that you need to perform, and it's a sleep. And on the right from the code, you can see how it can be actually represented as a persisted series of actions. Let's just go through to give some grasp on what's going on, how temporal works, and how this simple code can be basically serialized into a state in a database. When you schedule a workflow, your client sends to the server a command that creates a new workflow, a new history for this workflow that is basically workflow execution started, as you see on the first line, which has everything that is needed for the start of the workflow, and it's mostly input parameters of the workflow. After that, temporal server for you schedules the execution of this workflow by scheduling what we call a workflow task. Workflow task is basically an entity that represents a trigger of a user code. This trigger creates when there is any reason to unblock a user code. It's either a start of execution of user code or actually triggering it for any reason, for example, because of expiration of a sleep timer or some incoming signal. So temporal server creates workflow task and schedules it. It's what's going on the line number 2. After the temporal worker that actually executes this code and hosts this code, takes the event from the server, and that's the moment when temporal server registers that the execution of this workflow task actually started. Your code on the worker gets a chance to actually start execution, and it calls the activity. so user activities dot refresh status here is basically a call to a piece of code that can be executed on a separate machine. You want to trigger it, and you want to preserve the return value of this activity. That's what's going on in the history, in the following piece of history, when temporal server registers a completion of workflow task. Why? Because workflow right now is blocked. It's scheduled the activity, and it needs to wait for its result. So when workflow code is blocked, it means that it's a finish of the workflow task, and the execution flow gets released. After that, the activity actually gets scheduled by the server. It gets picked up by the worker, and the worker executes the code in the activity. So it creates the sequence of events. Activity task started, scheduled, started, completed. And when activity is completed, it means that user workflow code can continue execution because it has some trigger, which is finishing of activity execution to continue advancing. That's when temporal server schedules new workflow started event that gets picked up by the workflow code that now sees that activity is done, and it goes into the next line, which is wait for 30 seconds, for 30 days. When this happens, again, workflow code is blocked, and the execution get released, and workflow task get completed, and it get reported to the server. To get with this completion, we also tell the server that we need a timer for 30 days. And that's what gets recorded on the last line of the history. So the history actually registers the fact that there is a timer in this workflow that should be triggered in 720 hours. And temporal server will take care of it in a month when it happens. Why this representation is so powerful and so great? Whenever we fail on any step of this process, we can recover the state of our workflow by re-executing this code and feeding this history of events to actually recover workflow to the state where we left it, or it failed. For example, if in next month, somebody will reboot the server, which very likely will happen, the workers, when timer ticks and triggers the execution, Temporal SDK actually will be able to pick up the history from the server and recover the code in the state where we left it. That's one of the main functions of the SDKs in Temporal. So it basically provides a connection layer between the user code and this persisted history events and timers on the server side. Is there any questions about this screen? Because there is a lot of things going on here.
Yes, I have a question. So is it actually a working code snippet on the left?
Yeah, it is. I mean, to produce the output to the right, I had to write it in the run.
So temporal somehow preserves the snapshot of the state of the function, yeah, to recover or not. How the code will continue in the month from the code line 5, I don't know.
Yeah.
Next cycle, how it will happen?
So let's imagine that somebody turned off our server in the middle. There is no way to preserve a state of the process. There is no reasonable way that we can use in production. So this serialized representation is used to what we call replay the code. So we know that there is a workflow. It's persistent in the database. And temporal server in a month, when the timer ticks, will actually schedule a new workflow task for execution on a worker. And when this worker will get the task to execute, it will discover that, there is no workflow, like I need to recover. And what it does, it fetches the whole history from the server. It takes the code and it basically matches the history to the code. For example, here, what will happen? First line basically calls the activity, right? When instead of actual calling the activity, Temporal SDK will look at the history and see that this activity was already executed. So I don't need to repeat the step. And it will just use the return value that is recorded in the history. So the history preserves results of every operation, like activity execution. So using the history, code will be literally replayed till the state where we left it, and it will continue execution after that. Does it make sense? Because this is a little bit complicated concept, and it is kind of important to understand that temporal doesn't have a magic ability to just preserve the state of the workflow that currently exists in memory. When it needs the state to be recovered, it has to execute the code again based on and use the history that was preserved to recover the state.
Okay. So
We have a
I
little
tried
demo
to.
later on too that will show again.
Okay. Thank you.
Yeah, so it's just important to understand that Temporal SDK exists to basically provide this exact ability. When you call an activity, this call to the activity, it's not just a call to your code. This call is actually get intercepted by an SDK, and activity got scheduled on a worker, but it doesn't have to be if it already was executed. If it already was executed, in that case, SDK knows that it doesn't need to be rerun, and the persisted state will be used instead. So Temporal SDK is providing these ways to basically intercept control over the code to provide the guarantees that we are trying to provide.
Oh, thank you. I think further examples will be also helpful for me. So thank you for your answers.
Yeah, sure. Ticho, do you want to go? Is an example?
Really think about it. Like Dmitry explained how it is done, but when you write your workflows, you shouldn't really care, right? It's nice to understand, but when you write your workflow, you can just call workflow sleep 30 days and it just works. You can treat it as magic. You can understand the magic, but when you write the workflow, you don't really care. It is just the way you think about your code cannot, because it's not linked to a specific machine, it always can be recovered. It's kind of virtual, right? Like it's not linked to a specific box. So anything can go down, your code continues.
The most important reason why it's very good to understand that there is this underlying abstraction of a history is because workflow code has a set of limitations. What we usually say that workflow code has to be deterministic, which usually means that there should be no generation of random values right in the workflow code other than using the generators that Temporal SDK provides. Or there shouldn't be modification of a workflow code for already running workflows without consideration for determinism. Like, to understand this concept and limitations that we impose on workflow code, it is really useful to understand how it gets serialized, because if there is no understanding of serialization mechanic, probably these limitations will look artificial. But temporal SDKs have limitations on workflow code, and that's mainly the reason why, because it has to be replayable. We should be able to use the recorded history to recover the state. Ticha, do you want to go with an example?
Sure, I got maybe one or two slides, just easy ones, and then we go into demo and we can discuss it all together if that's okay. Okay. Yeah. So thank you. That was awesome. I mean, Dimitri can really explain this in a way that is just amazing. I just have a couple of small slides. Number one, I just wanted to talk about the Java SDK itself. Is just like other SDKs that Temporal provides, they're very unintrusive, meaning that, you know, specifically we're talking about Java, you can really use it within any framework. It's basically just a library that you include, and you can start using it, regardless of kind of like if you're building new applications, or if you have anything existing, for example, applications that you wanted to add workflows and Temporal into. Being based on a programming model, of course, that's what, you know, you can reuse your existing development environment, so you can keep using your IDEs. Even though, of course, we say Temporal is a workflow solution, typically, you know, people think that you have to adopt some sort of custom solutions and custom environments and blah, blah, blah. With Temporal, that's not the case. You can still use your IDEs. You can still deploy on, you know, Kubernetes, Docker, or whatever kind of platform that you have currently running or thinking about running in the future. And the same thing is with testing and debugging. Is you can, of course, as we'll see with our SDK, use JUnit 4 and 5. You can mock you know, activities and things like this, and really write your tests just like alongside the test workflows alongside your tests that you might already currently have the test other part of your systems as well. So kind of just to, you know, get started, and if you want to screenshot this, and of course we'll be on YouTube later, kind of, you know, one of the things that I wanted to talk about is how do you get started? Of course, we have our Temporal documentation. But specifically for Java SDK, we have a samples GitHub repository that includes a ton of different samples, and I think it's growing. The list of samples is getting bigger, and we're really listening to our community as far as the questions they have, and trying to provide usable samples that run out of the box for you to get a feel of all the different features that the Temporal Java SDK provides. We also have workshops. We've had 2 so far, and one is early next week. And here's a URL. And in these workshops, we kind of go deeper into specific cases. So if you have any, if you want to learn about some more advanced concepts of Temporal in the Java SDK, you definitely join there and ask any questions. And of course, we have a ton of YouTube videos, and we're adding them. We're creating more and more content. Our YouTube is growing so much. I'm sure you'll find a number of videos that will help you with getting started. So as far as, okay, we talked about what SDK does and how Temporal works and history, but kind of going back is how do you actually start using the Java SDK in my project? Well, you know, it depends on your build system. For Gradle, you just add a couple of dependencies. Most important one is the Temporal SDK, and here we have the version 1.8.1, which is the latest, and maybe Dimitri can talk about when he will release, you know, 1.9 and things like that, and what the timeline looks like currently. But yeah, the Temporal-SDK dependency is really kind of like the core dependency of the SDK. It includes all the APIs for writing your client code that invokes workflows, to actually writing your workflow code and using all the kind of constructs that you need to use to write your workflow orchestration, and Dimitri also touched upon that. You know, things like that. It also includes a lot of other things that are kind of more advanced, but we'll talk about that later. And of course, you need the testing dependency. The testing dependency allows you to have a full testing environment that is in kind of in memory, so you don't have to have a running temporal server running to actually run your tests. The cool thing about temporal testing SDK is that it has a kind of like a time advance feature. So even if you, for example, like Dimitri showed, his workflow waits for 30 days, your test can run in milliseconds. So you can really take the workflow that we've shown on the previous slide and test it out for maybe a year or two or whatever time period you want. And you don't, of course, you can test it within milliseconds. And there,
yeah, the cool thing, I just want to add, the cool
yeah,
thing that we have a fully sized server, like temporal server, which requires a database, etc. So it's relatively complex for operations. We have a simplified setup for development using just Docker Compose that is very easy to start a real server. But also we have a test server, which is extremely lightweight in memory implementation that can be used for unit tests. And it behaves extremely close to the production temporal server. So whenever we see a difference, we actually fix it, we keep it synchronized with the real thing. So it's extremely easy to use full real implementation in temporal in your unit tests.
Cool. Yeah. And just to show, yeah, the same thing for Maven. If you use Maven as your build system, pretty much only need 2 dependencies to set up, and that's that. You know, so it's very easy to get started from the SDK side in new or existing applications. All right, so I'll try to do a real quick demo now, and it's very kind of almost the same as what Dimitri talked about in his slide. It's a little bit different. We kind of, you know, didn't sync up completely on this, and it doesn't really matter. But, you know, what it does is we have very simple workflow method, which is it's kind of like the same as on the slide. Basically, in our workflow, in this case, instead of using one account or user ID and keep updating it every 30 days, in our test, we have a number of account IDs that we get, you know, from either end users or in your case, if you have applications, somebody can enter in some sort of web UI and use that as input to your workflow as data. And what we do is we basically loop through each one of our account IDs. And for each one of our account IDs, we want to notify it about some information. And this is just a small demo. But just in the previous slide, what we have shown is we invoke our activity. Our activity, as Dimitri explained, can be seen as a remote procedure call. So it will be handled, it's scheduling, and it will be handled by the temporal server. This activity can again be, as Dimitri said, executed on a completely different worker or different service that might be hosting that activity and has a worker that has it registered. And after that activity completes, we, just for the sake of this demo, sleep for 2 seconds, and you will see kind of why that is. We have also, of course, we use the temporal SDK in our worker as well. So both the workflow and our worker, and as you have seen, our kind of starter, or we call starters, our client application where we want to invoke our workflow execution. All of these things use the temporal Java SDK. So there is nothing, that you have to get extra to write a worker, or you don't have to get anything extra to write some sort of API to invoke your workflows. All the gRPC kind of under the hood communication between your code and the temporal server is handled by our temporal Java SDK. So you don't have to worry about things like that. But anyways, as we see, we have our workflow defined. We have a worker that Dimitri described is going to handle the communication with the server and help us with execution of our workflow code. And then we have a little bit of a what we call a starter, or it's a main method where we basically, again, use the temporal Java SDK to create something called a workflow stub. In this case, we do use a type stub. So we have our code that we define and we can call it in a type safe way. And then we basically call a notify workflow method, which is going to start our workflow execution. And then is going to, how do you say it, start the execution, scheduling and execution of our workflow. So one thing I wanted to show is, let's go ahead and start our worker. So our worker is going to be up and running, and our system is going to connect to a particular task queue. As you see here, task queue is just a string, so it has a name. In this case, it's just for demo my task queue, and you can think of those as kind of like an endpoints on the server that this worker is listening to, and as soon as a particular workflow task comes in into this task queue, that's dynamic task queue on the temporal server side, is going to pick up, it's going to read, like Dimitri said, this information and execute our code. What I'm going to start now is our starter. So in this case, what we're doing is using our Java SDK, going to request or the temporal server to schedule an invocation of our workflow. It's going to we're going to set a workflow ID, which is a business level ID. In this case, we define what the business ID is, so we can uniquely identify this workflow. And we also set a task queue for this particular invocation. And as you see, the task queue of our client and is my task queue, and the task queue that we have set on our worker when we created the worker here match. So when we request the start of this particular workflow on this particular task queue, and if the worker has this particular workflow, of course, registered that we're trying to evoke, this worker will pick up the task and start executing our workflow. So much talk, let's just run these things. Let me go ahead and run the starter. So if we see here that let's look at our Web UI and make this a little bigger so I can see it as well. We see that we have a workflow execution, and this is the Temporal Web Ui. If you start running the temporal server on Docker Compose, like what I'm running on locally right now, it is automatically there for you. And we can click on a particular workflow. Here we see kind of like a summary page. On the summary, we see the inputs that our workflow received, and these are the different accounts that we have added. And in this case, we already see the results because our workflow has completed. And under history, we can see what Dimitri talked about, the exact workflow history with every single history event that has happened during workflow execution. And we can see the different timers firing, our worker sending commands to the temporal server to schedule our activity executions for the 10 different accounts, and blah, blah, blah. Now, one thing that I wanted to show as part of the demo is we talk a lot about our temporal being able to resume from some failure. And Dimitri also said that, your code or your service that is running these workflows in the end can fail. And what happens if that happens, or you have to or you recover from it at some later time? If we look at the code that we actually have a for loop. And sometimes, especially for users, a lot of questions come up. Okay, I can kind of get how you can recover from it, but can you actually recover from inside a loop? And a lot of times, these type of questions come up, and yeah, we say, yes, you actually can. Even if you have a looping structure, of course, this loop has to be blocking on some sort of temporal API, such as invoking activities, or in this case, sleep. We can actually not only recover the workflow state after a failure, but we can actually recover it at the exact position in the loop. And to kind of demonstrate that, I wanted to, let me just go ahead and, yeah, I don't have to restart the worker, but yeah, it would be nice. I can run my workflow again. And if you see here, we're on account 1, 2, and so 3. And let me go ahead and stop my worker now. So what we have done is our workflow code ran through these 4 account IDs. It has performed 4 activity executions and 4 of the sleeps. And if we see in our web UI, we can see that our workflow is still running. So even though there are service that we're writing it has completely shut down, had some sort of failure, Temporal has still, our workflow is still running. And in our summary page, we see that under pending activities that we have a pending activity called notify, and we see that we are at temp 0, but something is going on. And if we look at the history also, we're kind of stuck here at activity task scheduled. And that's where kind of we're waiting for a worker to come back up, pick up the activity task, and proceeded with execution. So if we go now back to our code and start our worker back up, basically simulating that our service has recovered from a failure, and we have moved our code to a different service, we can see that we're continuing not from the beginning, but from account 5, 6, 7, 8, 9, and 10. And finally, after that, we see that our starter completes. And if we go to our web UI again, we see that we were able to recover this particular workflow execution for a worker failure and continue at the exact place where it was before at loop 5. And we are able to process all our customer accounts correctly, I guess is the word. All right, so that's kind of like what I had. Just like this last slide that I wanted to show is we are welcoming everybody into the community. Please, we need your input. We would love to get your input. We'd love to get your thoughts. How are you using the Temporal? How are you using the Java SDK? What kind of issues you're running into? And the best way to get involved is of course on GitHub. And here's the URL to our Java SDK GitHub repository. We have a forum, a community.temporal.io, and I strongly encourage you, if you have any sort of questions, beginner questions to really kind of hardcore questions, we're always there to answer and help you there. And of course, our Slack at temporal.io/Slack, and we are specifically for Java, we have a SDK-Java channel that you can join and get involved with the community to, and see, and also not only ask questions, but read about other people and how they're using Temporal and the Java SDK as well.